Hi, this is Mr. Manley. In this video, we're going to do a very little bit of graphing trigonometric functions. Just a pretty basic introduction to get an idea about what the graph looks like and doing some very minor adjustments to it. So here we have y equals sine x. And if we think about this as we do with any other graph where we have a table of values, x and y, where the input x here is an angle, and then we have some output y. Now, when we did graphing in the past, we might do something like, well, I'm going to look at 0, and I'm going to look at 0, maybe I'll look at 1, maybe I'll look at -1. But these aren't going to be convenient values with which to evaluate sine. So we're going to choose some convenient values here that we will be able to evaluate a little bit more conveniently. It turns out that 0 is good because I think I can figure out the sine of 0 pretty easily. I think a good place to begin is the unit circle, or a good place to look here is the unit circle. I'm just going to take this unit circle in the upper right hand corner here and say that if I've got the sine of 0, then so if I have an angle that can rotate around, I'm just going to start at 0, right? And on the unit circle, I know that at that point I have the coordinates of x is 1, y is 0. And then I also know from my study of trigonometry that the sine of an angle on a unit circle is equal to y over r. So the sine of this angle at 0 degrees is equal to y, which is 0, over r, which the radius on a unit circle is 1. So that's 0 over 1, which is 0. And that's what I'm going to fill in to the table. So there's my 0. Next convenient value I'm going to choose is pi over 2. Now if I look at a unit circle, I'll go over to this unit circle again, and I've got an angle rotating around, and I'm going to rotate up to pi over 2. And that's right there, right? Vertically up there. And I know what the coordinates of that point are there on the unit circle. If you don't have to know it, I mean, you can just look at your unit circle and see that the coordinates there are x is 0 and y is 1. Again, I remember that sine theta is equal to y over r. So in this case, my y value is 1. It's a unit circle, so my r value is 1. And that gives me 1 over 1 is 1. So the sine of pi over 2 is 1. Now my next convenient value is going to be pi. Go to the unit circle, rotate around to pi, and we'll get our xy coordinates there as -1, 0. And the y over r is therefore 0 over 1, which is 0. Can you guess what my next convenient value is going to be? If I say 0, pi over 2, pi, what would be next? That's right, 3 pi over 2 is going to be the next convenient value. Going to the unit circle, I'll rotate around to 3 pi over 2. And then I will take my coordinate there at 3 pi over 2 is going to be 0, -1. So the sine at that position is the y coordinate, which is -1, over r, which is 1. -1 over 1 is -1. And then my final convenient point is going to be 2 pi. And that's going to bring me right back around to where I started, right here on the positive x-axis, where my coordinates are 1, 0, and the sine value there is going to be 0. Now let's plot the points that we have on an xy axis. I've got point 0, 0. I'll put the 1, say, here. So the first point is 0, 0. The second point is pi over 2, 1. And then my third point is pi, 0. And notice that my scale is pi over 2. So I'm going pi over 2. So every 2 squares is counting off. Every 2 squares here is pi over 2. And then another pi over 2 gets me to pi. And then another pi over 2 will get me to 3 pi over 2. And that's my next point, is at 3 pi over 2, negative 1. Where's that? That's down here. And then I'm at 2 pi, 0. So hopefully you're following along there, and you can see the 4 points. 1, 2, or the 5 points. 1, 2, 3, 4, 5. And then it's not quite connect the dots, but close. It's going to be a curve. It's going to be a curve through those points. And then the thing about the sine function is that curve continues. All right, it'll continue infinitely like that in both directions. Something like that. And that's your basic sine function. There are two variations of this that I want to look at. The first variation is really simple. I'm just going to add a factor to the sine x. And that'll look like this. Just take the, go to the front here. Let's just say I'm going to go 5/2 sine x. And I've got y equals 5/2. And then say I want to graph that. All right, well, what do we have? We did have 1. We had it like that, 1. I'm going to change my scale now, because now maybe you can see I'm going to have to go up to a maximum of 2.5. So let me change my scale to just like I'll put the 1 there. All right, so 1 square amounts to 1. Now what we initially looked at was that the graph went like this. It went 0, 0, pi over 2, 1, pi, 3 pi over 2, and that's what the graph looked like. So all that's happening here is that I'm getting stretched. I'm getting stretched up to 5/2 or 2.5. So I'm just going to take these points here and stretch them out at the maximum. So I'm still going to have 0, 0, but at pi over 2, instead of 1, I'm going to go up to 2.5. And then I'm still going to have the pi at 0, and then the negative will go to negative 2.5. And then I'm still going to have 2 pi at 0. And then there's my graph. So what this did was, this 5/2, it did what's called changing the amplitude. It's changing the height of the function. Really pretty simple. Now, I don't think that any of the problems that I'm asking you to do are going to get into negatives, but I'll just mention that for a moment, that what would happen if this were negative? So y equals negative. And perhaps you recall from earlier studies in precalculus that that is a reflection. It's a reflection through the x-axis. So really this graph would just flip upside down. That's what the negative would do. So I would take these points here, and I would just switch them to the other side of the graph. So that'd be negative 2.5 here, and positive 2.5 here. And then the graph would look like that. So not too big of a deal. All right, the second variation that I want to look at is a little bit more complicated. So this one's going to be quite a bit more challenging. When I had the number in front, that was just giving us some sort of change in the vertical direction, a vertical stretch, or could be a vertical shrink. This case, when this number's changing, that's going to give us a horizontal. It's going to affect the graph horizontally. So what's going to happen is I'm going to take my basic sine function, which did, let's say, look like this. So it went 0 and then pi over 2, pi, 3 pi over 2, 2 pi. So that's what it looked like. And what's going to happen now is this is going to shrink or stretch in some way. And here's the deal with this. The basic function, y equals sine x, it takes that 2 pi from here to here. It takes 2 pi units to go through a single cycle. So digest that. That your basic sine function, y equals sine x, your parent function, if you will, takes 2 pi units to go through a single cycle. Now, what is happening whenever there is a variation at this spot in the graph, right here, where that 3 is, we're going to get a new cycle. And the way that we calculate that is simply to say that the new cycle is 2 pi, always 2 pi, divided by whatever that number is. So the 2 pi here is always determining our cycle, and then the 3 is going to give us the variation. So the 2 pi is actually the base period. That's the word that we're using, or the word that we would use. It's the period of the function. How long does it take to go through a cycle? And 2 pi is the base period, and then we're going to divide it by whatever this number is here to get the variation. So for this one, I want to go through a period of 2 pi over 3. All right, so let's see what that's going to look like graphically. All right, notice I've changed my scale on the x-axis. So I need to get a cycle to happen in 2 pi over 3, 2/3 of pi. So let's look at our scale here. There's pi. Now what's 2/3 of pi? Well, there's a third, there's 2/3, and there's 3/3. I need a cycle to happen in 2/3 of pi. So I'm still going to start at 0. And then I need to break this up, the 2/3, which is where I need the cycle to occur. I'm going to break that up into fourths. So are you seeing this? That I need one cycle to happen in that amount of distance. So 4 blocks. In 4 blocks, I need a cycle to occur. I'm calling this 1. This is my y scale of 1. All right, so I need to go through one cycle in 4 blocks. So how's that going to work? I'm going to go 0, 0, and then I'm going to go to the first block and go up to 1, and then to the second block and go down to 0, and to the third block, go down to -1, and to the fourth block, and back at 0. So I know that's going to be a little challenging for some, but we can get it, certainly, with a little bit of help. Understand definitely understand how to find the period, and then we need to figure out how to break the period up into 4 parts. And the 4 parts are going to be starting at 0, and then up to 1, back to 0, down to -1, back to 0. So that's actually pretty basic introductory sine graphing that I'm looking at there. Gets more complicated. But for our purposes, for the scope with which we want to go into things, that's where we'll stop.